So last time we looked at a problem like this, where we have a binomial that involves a radical, and we multiplied it by another binomial that involves a radical. For today's first example, we're going to look at a binomial times not just any other binomial, any other two-term thing that's involving a radical. It's actually going to be itself. And what did we do? We FOILed. First, 3x times 3x is 9x squared. Outer 3x times radical 2 is positive 3x radical 2. Inner, that's another 3x radical 2. And last, radical 2 times radical 2, that would be radical 2 times itself, radical 2 squared. We're just left with the 2 that's underneath. And here I've written 3x radical 2, but the reason I've done that, is because I like it when the radical is at the end. We don't have that confusion. Technically, the coefficient of x here would be 3 radical 2. This is 3 radical 2x. But when we write it like this, there is very easily going to be confusion between this and what is definitely not the same, 3 radical 2x. Where does the radical actually stop? We avoid that altogether by making sure that the radical factor is written last. So instead of 3 radical 2x, 3x radical 2. Anyway, what is 3 radical 2 plus 3 radical 2 in order to combine these like terms? Because 3 radical 2 x's plus another 3 radical 2 x's. Well, they're like radicals, and 3 plus 3 would be 6 of the radical 2's. So when we combine here, we get 3x plus 3x equals 6x radical 2 plus 2 on the end, and then the 9x squared in the front. So like I said, this way of writing it, that's for most clarity, but also correct would be 9x squared plus 6 radical 2x, being very careful that that radical 2 or that radical sign does not extend over the x, plus 2. Why am I starting with this today? Well, what does it mean when we write something times itself? It means squaring. What I want to drive home here is a fact that radical A plus radical B squared would not be A plus B. Now, radical A times radical B squared, or radical AB squared, would be AB. That works for multiplication. It works for division. It does not work for addition or subtraction. And this should be all the proof you need. Here, we're squaring radical terms. And do we get the two things under the radical as the answer? Do we get an answer with no radicals? No, we get a 3-term thing, not a 2-term thing, a 3-term thing, and the second term still has a radical in it. This may seem like a weird thing for me to be pointing out right now, but like I said, as we continue with the examples, you're going to see why I'm bringing this up. And we didn't have to FOIL. Remember that when we have a binomial squared, we have a special formula. Square the first thing, so square the 3x, plus in the binomial, so plus here, 2 times the two things multiplied together. 2 times 3x would be 6x times radical 2. Well, I don't want to do that yet. Let me just write it out. 2 times the first times the second, and then always plus, no matter what's inside, the second thing, radical 2 squared. Squaring 3x gives us 9x squared. 2 times 3x, that's the 6x times radical 2. That's our 6x radical 2, or 6 radical 2x. And then radical 2 squared, square root squared leaves what's underneath. There's our plus 2. So remember, we do have that formula for a special product. Square the first, and then plus or minus whatever's inside. And then 2 times the first times the second. And then always plus, no matter what's inside. And then square the second. It's a shortcut. Makes things go a little faster. What was the other special product that we have? Well, another special product we have when we multiply binomials was the multiplication of conjugates, where we were multiplying two things that look exactly the same except for one difference. That difference is one of them is adding the two things, the other is subtracting the two things, but the two things themselves are the same. Remember, that was a plus b times a minus b, and we got a squared minus b squared. It's the difference of squares formula. Multiplication of conjugates gives us a difference of squares. Just like if we factor a difference of squares, we get two things, one plus, one minus, conjugates. Multiplying these does give us a two-term thing. And when we square these things, that should get rid of the radicals. So this one would give us a two-term thing with no radicals. Let's do the long way first, though. Let's just FOIL it. Foiling would be first 4 radical 5 times 4 radical 5. And then outer 4 radical 5 times negative radical 6. 4 radical 5 times radical 6 with a minus, because positive times negative is negative. Inner, that's going to be plus 4 radical 5 times radical 6. If you have them in the other order, that's okay, but they are still the same thing. And then last, so we just did inner, now we do last. Positive times negative is negative, radical 6 times itself. these terms are the same. They cancel each other out. So we're left with 4 radical 5 times itself, or 4 radical 5 squared, and then minus radical 6 times itself, or radical 6 squared. And that's that difference of squares formula. We can skip over the FOILing step when we have this special product. We can skip over the FOILing and we can go, hey, these are two things that are exactly the same, except one's adding them and the other's subtracting them. That means they're conjugates. It would be the first thing squared minus the second thing squared. It's always a difference of squares. There is no such thing that's going to give us a sum of squares, at least not with the real numbers. We'll see what happens later on today. Okay. So the first thing, 4 radical 5, the second thing, radical 6. Same thing we got with the FOILing. Let's finish that up. Squaring 4 radical 5 would be squaring the 4. 4 times 4 is 16. And then squaring the radical 5. Radical 5 times itself is just 5. Minus. Radical 6 times itself, that's 6. 16 times 5 is 80. 80 minus 6, 74. So we multiplied two things together that involved radicals, and because it was this special setup, this multiplication of conjugates, the radicals went away. Again, it might seem weird that I'm pointing out that specific thing, but you're going to see why as we progress. I want you to consider the expression 1 over radical 2. Now, radical 2, if you took the square root of 2 on a calculator, would be 1 over estimated 1.414. And if we wanted to actually divide this, 1 divided by 1.414. Now you might be saying, hey, that's no problem. I just used the calculator for the radical 2 to get the 1.414. You shut up now. You shut up with that. I'm trying to make a point here, and it's a good point. So let's forget about the fact that we used a calculator for this. Now we're back in, let's divide by hand land. So first of all, we wouldn't be allowed to have a decimal on the outside. So 1, 2, 3 spaces over. Here would be 1, 2, 3 spaces over. End up here. We'd have to look at 1,000 divided by 1414. So complicated. Makes me not want to do it at all. Now, what if I told you that 1 over radical 2 could be expressed another way? It could actually be expressed as radical 2 over 2, and I'll show you how to do this in just a second. I'm going to tell you why it's important first. Radical 2 over 2, that's 1.414 whatever divided by 2. I could really quickly say that that's about 7.707. Just kind of took half. Dividing by 2 is easy, even if you did it by hand. So it's easier to divide by a number than it is to divide by a radical. So the convention is we don't want radicals in the bottom. We don't want that. So what we're going to do depends on what exactly is on the bottom, what the situation is. Our strategy is always going to involve the fact that anything times 1 is itself. We just have to be clever about the form of 1 we choose. Anything over itself is 1. So we want to multiply by something over itself in a way that rewrites this as something that does not have a radical on the bottom. It turns the bottom from an irrational number to a rational number. And that's why this process is called rationalizing. Wait for it. The denominator. Wow. Rationalizing because we're turning something irrational into something rational. Not the whole thing. It still has a radical. It's still going to be irrational overall. But what will be rational is the denominator. Right now, it's not. Hey, this is just a square root. A square root times itself leaves us with what's underneath. And since we're supposed to be multiplying by 1, if we want to multiply by the square root of 2 on the bottom, we multiply by the square root of 2 on the top. 1 times the square root of 2 is the square root of 2. That is how we got that earlier. Let's do another. If we have 2 over radical 3, that's bad. We want to rationalize the denominator. We don't want to write our final answers with radicals in the bottom. Well, this is a square root of 3. If we multiply by another square root of 3, that'll just leave us with 3. And since we want to be multiplying by 1, radical 3 over itself. So 2 radical 3 over 3 would be 2 over radical 3 in rationalized, with a rationalized denominator. Now, by the way, there might be a specific problem at some point that wants you to rationalize the numerator. That would just be the flip of this. We wouldn't want any irrational numbers in the numerator. That is very uncommon. It would be specifically asked for, and it would just be training you for later on when it might be an easy step in a larger problem. That's well beyond this course, but the idea of being able to rationalize, whether it's the denominator or the numerator, that is what we're focusing on here. It's what you should be able to do. Let's say we had the square root of 1/8. Now, at first glance, you might be thinking, well, what about the square root of 1/8? What's wrong with this? Well, what's wrong with it is when we see the square root of an entire fraction, we know that means that we can have square root over square root. And that means that hiding in square root of the fraction is in fact a radical in the denominator. We need to deal with that. We can simplify a little first because the square root of 1 is just 1. So what we're really looking to rationalize when we are looking at square root of 1/8 is 1 over the square root of 8. And if we multiply that by the square root of 8 over itself, multiplying by 1, that's going to give us square root of 8 over 8. Cube root. Cube root, let's look at the cube root of 64 over a. Again, fractions inside of the radicals means that hiding is a radical in the denominator. Ooh. Cube root of 64 over cube root of a. There we go. Just avoiding the light spot. And the cube root of 64 is 4. So what we're looking to rationalize is 4 over the cube root of a. Now here, we can't just multiply by the cube root of a over itself. Because unlike a square root, where a square root times a square root does get rid of the radical, because it's a square underneath a square root, and the square root cancel away. It's not a square that cancels a cube root. What is it? Oh, and this, oh, that's a mistake. That is 3 square root there. That's what I warned you not to write. Let me make sure that 3 is inside the little pocket. We would need yet another cube root of a. Why? Because a cube root of a times a cube root of a times a cube root of a would be a cube root of a cubed. And those do cancel and just leave us with a. But what would we have on top? We would have 4 times 2 of these. But it wouldn't be 2 cube root. That would be if we were adding. It would be the cube root times itself. Or the cube root of a times the cube root of a is the cube root of a times a. Cube root of a squared is how we would write that. 4 cube root of a squared all over a. I'm going to do another. This time I'm going to do the 4th root of 16 over b. Which would be the 4th root of 16 over the 4th root of b. And the 4th root of 16 is 2. We need to rationalize to get rid of the 4th root of b on the bottom. How many more would we need? Well, we would need the 4th root of b cubed, because that's what gives us the 4th root of b to the 4th. B times b cubed is b to the 4th. So we need a 4th root of b cubed on the top because we're multiplying by 1. And let me actually move this down here so I could actually write that without, well, 2 times the 4th root of b cubed. There we go. So again, the top is 2 times the 4th root of b cubed, and on the bottom, the 4th root of b to the 4th would be b. Assume that all variables are positive real numbers, of course, and then we don't have to worry about the absolute value signs. Let's look at this now. Let's look at negative 2 over 2 plus radical 6. We want to rationalize this. Your first instinct might be, by the way, this is wrong. Don't write this down unless you're going to like put arrows at it and say wrong. Hey, radical 6 over radical 6, that's worked before. But while that might get rid of multiplying by this, what's actually happening is that we're distributing. So you would end up with 2 radical 6 plus 6. You've taken care of not having a radical on the bottom right, but you've given yourself a radical on the bottom left. Hey, you kind of realizing why I was talking about what makes radicals go away? Hopefully your spidey sense is tingling. Your next instinct, which would also be wrong, might be, well, if multiplying the radical by itself got rid of the radical, I'll just multiply this by itself. That won't work either because that's squaring a binomial. And we just looked at the fact that that would get rid of the radical at the beginning and the radical at the end. But it's going to be a 3-term thing that still has a radical in the middle. And while this will simplify to 4 plus 6 is 10 plus 4 radical 6, it does not get rid of the radical. So we try again. Squaring isn't going to do it. Well, that's why we discovered the fact that multiplying by the conjugate, if we have a plus radical 6, if we make that minus radical 6, that is a difference of squares. 2 squared minus radical 6 squared. And that's 4 minus 6. And that's negative 2. Let's figure out what the top is. If we're multiplying by 2 minus radical 6 on the bottom, since we're multiplying by 1 overall, that form of 1 is 2 minus radical 6 over itself. We're distributing on the top. Negative 2 times 2 is negative 4. Negative 2 times negative radical 6. Negative times negative is positive 2 radical 6. So negative 4 plus 2 positive radical 6. We can factor a negative 2 out the front. That would leave us with 2 minus radical 6. Is that right? Negative 2 times 2 is negative 4. Negative 2 times... Oh, look, it's the same form. I factored it right back out. And why did I factor it right back out? Well, there's a negative 2 on the bottom. If I take this negative 2 from the top, I can cancel those negative 2's, and my answer is just going to be 2 minus radical 6. Not only did I rationalize the denominator, I was able to get rid of the denominator entirely. So I can see you leaving the answer maybe like this. -4 plus 2 radical 6, and it was over -2. I can see you leaving it like that. That would be like not reducing a fraction all the way. And if you don't factor out the -2, then you at least have to be careful to split up -4 over -2 plus 2 radical 6 over -2. If you're dividing by -2, you can't just do one or the other. It has to be both. Why? How would you add these fractions? There's a common denominator. So I would keep the common denominator and add the top. Well, look at the previous line of work. Keep the common denominator, add across the top. Splitting is what has to happen because it's adding the fraction in reverse. I've said before, it's important to know how to work with fractions because later on, the rules are going to make sense because they're just the fraction rules. If you wanted to rely on calculators or something like that with fractions in the past, you're going to have to relearn how to do all of this. That's why it's important to know how to add fractions by hand, because then this step is natural to you. You don't have to wonder, why did he do that? You know why I did that, because that's how you add and subtract fractions. And then from here, negative divided by negative is positive, plus positive divided by negative is negative, plus a negative is subtraction. 2's cancel, 2 minus radical 6. So that's how you rationalize when there is a binomial on the bottom. When there's more than one term, you have to use the conjugate to get the difference of squares. Let's do one more of these. Let's rationalize 8 over 3 plus radical 5. Well, 3 plus radical 5 means 3 minus radical 5 is what gets rid of it. Over itself, distribute on top, FOIL or difference of squares on the bottom. 3 squared minus radical 5 squared. On top, 24 minus 8 radical 5, distributing that 8. So 24 minus 8 radical 5 over 9 minus 5. That's 24 minus 8 radical 5 over 4. Let's just split it up. Let's not worry about factoring. 24 over 4 minus 8 radical 5 over 4. That gives us 6 minus 2 radical 5. This 6 minus 2 radical 5 is exactly the same as 8 over 3 plus radical 5. But we don't want that radical 5 in the bottom. We rationalize, we get our answer as 6 minus 2 radical 5. we have a power property, which basically says any solution to the equation P equals Q is also going to be a solution to the equation P to the N equals Q to the N. It does not say that these equations are equivalent. It only says that each solution of the original equation is also a solution of the new equation. So our strategy to solve equations involving radicals, or really powers, is that we do something on one side and also do it on the other. To get rid of square roots, we square. To get rid of squares, we square root. Let's take a look at example 4. It's going to make a lot more sense when we see this in action. X minus radical 15 minus 2x equals 0. So first, we want to get this radical by itself. So we're going to start off, oh, look at that. We have 0 on one side. Let's just add the radical 15 minus 2x to the other side. We're going to undo this square root by squaring both sides. So x squared equals 15 minus 2x. Now get everything on one side. Add the 2x, subtract the 15, get 0 on the other. Factor. Numbers that multiply to negative 15 and add to positive 2 are 5 and negative 3. So x equals negative 5, x equals positive 3. We want to check our answers all the time in radical equations. So, we're going to check this twice. Once for x equals negative 5, once for x equals 3. If we plug in negative 5, we get negative 5 minus radical 15 minus 2 times negative 5 equals 0. Negative 5 minus 15 plus 10 equals 0. Negative 5 minus radical 25 equals 0. Negative 5 minus 5 equals 0. Negative 10 equals 0. Well, wait a minute, that's not true. It's not true. X minus 5 is not a solution. Try it with 3. (15 minus 2 times 3 equals 0. 3 on the outside here. 3 minus 15 minus 6 under the radical equals 0. 3 minus radical 9 equals 0. 3 minus 3 equals 0. 0 equals 0. Check. So x equals 3 is our only answer. Let's look at example 5. Solving an equation containing two radicals. Radical 2x plus 3 minus radical x plus 1 equals 1. We want to get one of the radicals by themselves. So I'll just keep this radical 2x plus 3 on the left, and I will add the other one over. 1 plus radical x plus 1. Now that we have a radical by itself, square both sides, but be careful. Gives us 2 plus 3 on the left, and we have to FOIL or use the formula for squaring on the right. Square the first one. 1 times 1 is 1. Outer and inner. 1 times radical x plus 1 plus 1 times radical x plus 1 gives us 2 radical x plus 1s. Plus, if we square radical x plus 1, we get x plus 1. So this is why we worked on squaring things like this in the radical section. Now here's the thing. When you have two radicals in the equation, you're going to get to a point where you still have a radical left because of how we square this. So once we combine all our like terms, 2 plus x plus 2 radical x plus 1, 1 plus 1 is 2. We're then going to get everything on one side, leave the radical on the other. So subtract the 2, subtract the x. X plus 1 equals 2 radical x plus 1. We don't have to divide by 2 everywhere because we can just go ahead and square now. If it was 2 plus the radical, we wouldn't be able to just do that. That would cause us something with a radical still. But 2 times the radical, we can do that. X plus 1 squared is x squared plus 2x plus 1. 2 squared is 4. Radical x plus 1 squared is x plus 1. We still have to multiply those together. So distribute 4x plus 4. Get everything on one side, 0 on the other. So subtract 4x from positive 2x. Subtract 4 from positive 1. The numbers that multiply to negative 3 and add to negative 2 are negative 3, positive 1, which means x equals positive 3, and x equals negative 1. We now have to check that in the original equation. Which was radical 2x plus 3 minus radical x plus 1 equals 1. So let's do this check. So radical 2 times 3 plus 3 minus radical 3 plus 1 equals 1. Radical 6 plus 3 minus radical 4 equals 1. Radical 9 minus radical 4 equals 1. 3 minus 2 equals 1. 1 equals 1. We're good. With the negative 1, radical 2 times negative 1 plus 3 minus radical negative 1 plus 1 equals 1. Radical negative 2 plus 3 minus radical 0 equals 1. Radical 1 minus radical 0 equals 1. 1 minus 0 equals 1. 1 equals 1. Both of these check. Both of these are in our solution set. We like how this one looks. Cube root of 4x squared minus 4x plus 1 minus cube root of x equals 0. You're probably thinking, what do you mean we like how this looks? We don't like how this looks. When we have 0 on one side and 2 radicals, it's so much easier. Because look what happens if I add this cube root over. 0 plus the cube root of x is just the cube root of x. We have cube roots isolated. How do we get rid of cube roots? We cube both sides. Cubing a cube root just gets rid of it. We have 4x squared minus 4x plus 1 equals x. Let's get 0 on one side, so subtracting x gives us 4x squared minus 5x plus 1. And we're going to factor this. Now, you've seen me do the AC method multiple times. You should know how to factor using the AC method at this point. I'm going to show another method which is going to work. So the first step is if we have a common factor in all the terms, we're going to have to factor that out first. In an equation, you factor it out, you divide by it. 0 divided by that number keeps 0 on one of the sides. Now, we still need to find AC. We still need the numbers to multiply to be 4 times positive 1. We need it to multiply to be positive 4 and add to be negative 5. But we're going to be able to do something with just our binomials. So the numbers that multiply to 4, add to negative 5, are minus 4 and minus 1. What do we have here? 4x squared. So let's put 4x and 4x. Yes, I know that that's 16x squared, but bear with me. Our numbers, negative 4 and negative 1, we're going to put them right in. Nothing in common here, so we're not going to divide by anything. What do we have in common here? A 4. Let's divide by 4. So this is x minus 1 times 4x minus 1 equals 0. You don't believe me? Let's do the actual AC method, side by side. So we found the numbers that multiply to AC, positive 4, add to B, negative 5, that's negative 4 and negative 1. Use that to split up negative 5x into negative 4x minus x, negative x minus 4x. Factor by grouping. Take out a 4x, we're left with x minus 1. Factor out a negative 1, we're left with x minus 1. X minus 1, 4x minus 1. Same thing. If we finish solving here, we get x equals 1, positive 1, and x equals positive 1/4. We need to check these. In the original, so in cube root of 4x squared minus 4x plus 1 minus cube root of x equals 0. We're going to check first x equals 1. So cube root of 4 times 1 squared minus 4 times 1 plus 1 minus cube root of 1 equals 0. Cube root of 1 is 1. 1 squared is 1. 4 times 1 is 4. Minus 4 plus 1. So this is the cube root of 1. Minus 1 equals 0. 1 minus 1 equals 0. 0 equals 0. This one checks. So x equals 1 is an answer. Let's do it again with x equals 1/4. Be careful. 1/4 squared minus 4 times 1/4 plus 1 minus the cube root of 1/4 equals 0. Don't panic. We're doing this with x equals 1/4. 1/4 squared is 1/16. 4 times 1/4 is 1, so minus 1 plus 1, and those cancel. Yes, I know we can't do anything with the cube root of 1/4. Be patient. 4 times 16 is 4/16, which reduces to what? 1/4. Cube root of 1/4 minus cube root of 1/4 is 0. 0 equals 0, checks. So our answers are both x equals 1 and x equals 1/4. Let's solve 2t equals the square root of the trinomial 4t squared plus 4t minus 19. We have the radical by itself. Let's go ahead and square both sides. Two t squared is 4t squared. Square a square root gets rid of the square root. If we subtract 4t squared from both sides, those cancel away. We're left with 0 on the left equals 4t minus 19. Add 19 to both sides, 19 equals 4t. Divide both sides by 4. T equals 19/4. Three minus the square root of x plus 2 equals the square root of 3 minus x. We have a radical by itself. That's great. We can square both sides right away. We get a radical by itself. We can square both sides to simplify a bit. And the radical and the square undo each other. This just equals 3 minus x on the right. On the left, be careful because it's this times this. Foil it with itself. 3 times 3 is 9. And then we're going to have minus 2 of these things multiplied together. 3 times the radical x plus 2. That's the outer and the inner multiplied together. Last, square the square root, square this. It's plus x plus 2. So what I just did was take that times itself. First, outer, inner, last. Or use the special formula. Square the first minus 2 times the first times the second plus square the second. Let's clean this up a bit. This is 9 minus 6 radical x plus 2, not subtracting first. Order of operations says we multiply first. Nine plus 2 is 11. 11 minus 6 radical x plus 2. plus x equals 3 minus x. Do I do 11 minus 6 to get 5? Absolutely not. These are multiplied together because of order of operations. They cannot be separated. These are not like radicals. They cannot be subtracted. Let's get this radical by itself. I'm going to subtract 11 from both sides. I'm going to subtract x from both sides. That's going to give me negative 6 radical x plus 2 equals negative 8 minus 2x. And now I can square both sides. This won't be a problem. Let me move it up first. And I square this side. I square this side. Here, negative 6 times negative 6 is positive 36 times x plus 2. Over here, square the first. Negative 8 squared is positive 64. Minus 2 times negative 8 times 2x plus 2x squared. So I'll even write this as negative 8 squared for now. So again, same formula. Square the first, minus 2 times the first times the second, plus square the second, or FOIL it with itself. You'll get 64 plus 2 times 8 is 16 times 2 is 32 x plus 4 x squared. And over here, distribute the 36, 36x plus 72. Okay. I'm going to move everything over to here. So first I'll have my 4x squared. Then I'm going to subtract 36x. Positive 32 minus 36, that's minus 4x. Positive 64 minus 72, that's going to be the opposite of 72 minus 64. I'm just doing that math off to the side, nothing you'll have to copy. That's 8. So positive 64 minus 72, that's negative 8. I can divide both sides by 4. X squared minus x minus 2. I need two numbers that multiply to give me negative 2, that add to give me negative 1. And then I'll be able to factor with x and x. These numbers are going to be negative 2 and plus 1. They multiply to give me negative 2. They add to give me negative 1. Minus 2 plus 1. So x minus 2 equals 0. X plus 1 equals 0. We get x equals positive 2. we get x equals -1. All of that work to a -1 are the answers.